Far beyond the reach of sunlight, past Neptune's deep blue orbit, there lies a chilling, silent frontier, an ancient and frozen wilderness where the forgotten pieces of our solar system's past have drifted for billions of years, untouched and undisturbed. In this deep space graveyard, time stands still. Imagine a place so cold and so far that even the sun is just a faint glow in the distance. It's here, in this shadowy stretch of space, that the Kuiper Belt begins, a massive ring of icy alien objects circling the outer edge of our cosmic neighborhood, like a ghostly halo made of frozen secrets. I'm Paul MC Torthen, and you're watching Universe in Motion. To reach this mysterious zone, our journey starts right here on Earth. We blast off into the vastness of space, leaving our blue planet behind and soaring past the dry, desert-red landscapes of Mars. Then, we race beyond the swirling gas giants, Jupiter with its churning storms and mighty moons, and Saturn with its golden rings spinning like ancient clockwork. But we're not done yet. We keep going, out past the icy blue sentinels of Uranus and Neptune, until the stars seem closer than the planets. That's when we finally arrive at the Kuiper Belt. But this isn't just a random collection of distant space rocks. It's a frozen archive from the dawn of time. Locked inside these icy bodies are the untouched ingredients of our solar system, like a time capsule sealed 4.6 billion years ago. Among them are strange miniature worlds, some the size of continents, each one holding clues to how planets form, how comets are born, and maybe even how life itself began. These odd frozen relics have left astronomers baffled for decades, sparking questions we're only now beginning to answer. Today, we're taking a deep dive into the Kuiper Belt to uncover the bizarre worlds that float silently in the darkness, far beyond the planets we know. With each discovery, we're learning more not just about these icy wanderers, but about the hidden forces that shaped everything in our solar system, including Earth. So strap in as we peel back the layers of mystery and reveal what's really lurking in the cold outer shadows of our cosmic home. Most of the asteroids we've discovered are huddled in a single region of space known as the asteroid belt, a vast cosmic junkyard that orbits between Mars and Jupiter. These rocky remnants from the early solar system vary widely in size, from the behemoth Vesta, which is about 525 kilometers wide, roughly the distance between London and Belfast, to tiny fragments only a few dozen kilometers across. You'd think with all that debris it must weigh a ton, right? Surprisingly, if you added up the mass of every asteroid in the belt, it would still equal only about 3% of the Moon's mass. That's like realizing an entire junkyard of scrap. Metal weighs less than your car. But the belt isn't empty by any means. It's a region teeming with clues about the past, a leftover stage where planets might have formed, but never did. Now these ancient wanderers silently orbit the sun, caught in a gravitational tug-of-war they never managed to escape. As we venture beyond the asteroid belt, we enter a realm ruled by giants. Here lie Jupiter, Saturn, Uranus, and Neptune, massive. Planets made of gas and ice that dwarf everything around them. Their immense gravity has shaped the fates of many celestial bodies, acting like bouncers at the edge of the solar system, flinging intruders away or pulling others into orbit. These giants dominate the outer reaches, but even they are not the end of our journey. Pushing past Neptune, which orbits 30 times farther from the Sun than Earth does, we cross into a truly remote and frozen frontier, the Kuiper Belt. This vast region extends from 30 to 50 astronomical units and is packed with icy objects, some the size of cities, others as large as planets. It's the final resting place of ancient materials that never made it into the spotlight of planetary formation. Think of it as a deep freezer preserving cosmic leftovers from over 4.6 billion years ago. In this frozen expanse, we find a treasure trove of dwarf planets, Pluto, Haumea, Eris, Makemake, and countless smaller icy objects all drifting in near silence. Just like the asteroid belt, the Kuiper Belt holds debris from the dawn of our solar system, but its composition and history are very different. Kuiper Belt objects, KBOs, are some of the oldest and most untouched relics from the solar nebula, the cloud of gas and dust that gave birth to the sun and planets. Once upon a time, these frozen fragments could have formed another planet, but Neptune's gravity got in the way, constantly stirring the region and preventing these icy bodies from coalescing. Instead of becoming something new, they stayed, scattered and cold, forming what is now a colossal ring of frozen chaos. Unlike the rocky asteroid belt, the Kuiper belt is composed mainly of methane, ammonia and water ice, a cosmic slush of frozen chemicals orbiting in a wide, donut-shaped band around the Sun. This belt isn't just big, it's mind-boggling in scale. It holds hundreds of thousands of icy bodies larger than 100 kilometers, plus over 1 trillion comets, and untold amounts of smaller debris and dust. But don't picture a dense, traffic-jammed belt. In reality, the distance between these objects is enormous. On average, they're separated by 0.02 to 0.1 astronomical units. That's about 3 to 15 million kilometers apart. Imagine being stuck in the middle of a desert with the nearest object millions of kilometers away. Out here in the deep, cold darkness, these icy bodies float undisturbed, like ancient ghosts of the solar system's past, quietly holding secrets about how planets and comets formed, and maybe even how life began. But the story doesn't stop at the Kuiper belt's edge. Just beyond its frozen boundary lies another enigmatic zone known as the scattered disk. Here, some KBOs have been flung into highly elliptical and tilted orbits that stretch nearly 1,000 astronomical units from the Sun. These scattered objects were hurled outward by Neptune's gravity long ago, sent into cosmic exile far beyond the calm of the main belt. While the asteroid belt and the Kuiper belt both hold ancient materials and orbit the Sun, the Kuiper belt is vastly more expansive, colder, and composed of very different substances. It's not just a distant version of the asteroid belt. It's a frontier all its own, full of surprises and mysteries that scientists are only just beginning to unravel. And yet even now we haven't reached the final boundary. Surrounding everything, every planet, asteroid and frozen body, is the Oort cloud, a vast and distant sphere of icy objects that may extend as far as 100,000 astronomical units from the Sun. We can't see it directly, but its gravitational influence and the comets it sends our way make its presence undeniable. Unlike the flat ring-shaped Kuiper belt, the Oort cloud is thought to be spherical, surrounding our solar system like a bubble. It's the source of long-period comets that take thousands of years to complete an orbit. The Kuiper belt, in contrast, is the birthplace of short-period comets, those with orbits of less than 200 years, like Halley's Comet, which returns to Earth's skies every 76 years. The Kuiper belt we see today is just a shadow of what it once was. Originally, it may have contained 7 to 10 times Earth's mass, but the chaotic migrations of the gas giants scattered most of that material into space, leaving behind only a small fraction, about 10% of Earth's mass. And it's still fading. Over time, collisions break objects into smaller fragments. Some of that dust is pushed away by solar radiation, while others are flung toward the inner solar system, becoming the spectacular comets we see from Earth. One such example is Shoemaker-Levy 9, a comet that broke apart and crashed into Jupiter in 1994, in one of the most dramatic cosmic events ever observed. These icy messengers are constant reminders that even in the quietest corners of space, the story of our solar system continues to unfold, with every orbit, every collision, and every glowing tail streaking across the sky. Imagine two colossal structures at the far edges of our solar system, sculpted by billions of years of cosmic evolution. One of them, the Kuiper belt, stretches out like a massive frozen donut, a ring of icy, dusty debris orbiting the Sun far beyond Neptune. The other, the mysterious Oort cloud, surrounds everything in a vast, invisible sphere made of countless frozen fragments floating silently in the dark. Though vastly different in shape and distance, the Kuiper belt lies tens of astronomical units from the Sun, while the Oort cloud may stretch as far as 100,000 AU. They share a surprising connection. Both are the birthplaces of comets. The Oort cloud sends long-period comets on epic journeys that can last tens of thousands of years, while the Kuiper belt is home to the shorter-period comets that loop around the Sun in under 200 years. These icy messengers light up Earth's skies, flashing brilliant tails while carrying stories from the dawn of the solar system. But the Kuiper Belt we see today is only a ghost of what it once was. In the earliest days of the solar system, this icy region may have held as much as 7 to 10 times the mass of Earth. However, as the giant planets, Jupiter, Saturn, Uranus and Neptune, shifted their orbits, their immense gravity scattered most of that mass into deep space. What remains now is less than 10% of Earth's mass, and even that is slowly fading. Occasionally, objects in the Kuiper Belt collide and shatter, sending smaller fragments drifting into space. The tiniest particles, just dust in the cosmic wind, are eventually pushed out of the solar system by the relentless force of solar radiation. Like an ancient ruin, the Kuiper Belt is crumbling piece by piece, its past grandeur only hinted at by what survives today. That destruction, however, also creates beauty. Sometimes these shattered fragments, or the tug of Neptune's gravity, send an object on a new course, one that leads it toward the sun. That's how short-period comets are born. As these icy bodies draw closer to our star, the sun's heat causes their frozen surfaces to vaporize. Gases and dust erupt into space, forming the glowing tails that streak across the sky. These are not just spectacular sights. They're frozen time capsules, holding clues to how our planets, moons, and even life itself may have begun. Each comet carries ancient secrets, now made visible with every shimmering pass through the inner solar system. Some of these comets have become cosmic legends. Halley's Comet, perhaps the most famous of all, returns to Earth's skies every 76 years, recorded by civilizations for over 2 millennia. Then there's Comet Shoemaker-Levy 9, which in 1994 delivered a jaw-dropping moment in space history. It broke apart and slammed into Jupiter in a series of explosive collisions, the first ever recorded impact between two solar system bodies. The scars left behind were visible for months, a dramatic reminder that our solar system is not a quiet place. Even in the outer reaches where ice drifts in the dark, change is always brewing. These celestial wanderers and their unpredictable paths tell us that space, for all its silence, is full of motion, drama, and the power to reshape worlds. Imagine hearing on the news that a mysterious space rock named Asteroid 2024 YR4 is drifting somewhere near Earth. Sounds scary, right? But here's the thing. Even though there's a tiny chance it could come close to our moon, or an even smaller chance of reaching Earth, it's not something you need to lose sleep over. The truth is, short-period comets that come from the Kuiper Belt, a distant icy zone at the edge of our solar system, won't be bothering us for at least hundreds of years. So, for now, Earth is in the clear. But what's far more fascinating than any threat is what the Kuiper Belt still holds, a nearly endless playground of cosmic relics. Despite being just a fraction of what it once was, this frozen frontier offers some of the most fascinating objects in our solar system, waiting to reveal the secrets of our cosmic origins. Unlike the Oort cloud, a region so far we haven't even managed to reach, the Kuiper Belt has actually been explored, and not just through telescopes. One spacecraft made the impossible journey and showed us things we never imagined. Meet New Horizons, NASA's space probe that didn't just cross the solar system, it rewrote history. Before its journey, most of what we knew about the Kuiper Belt came from powerful Earth-based telescopes and Hubble's distant glimpses. But in 2015, New Horizons gave us the closest look we've ever had at the dwarf planet Pluto. And it didn't stop there. In 2019, it made the most distant flyby ever conducted in space exploration, zooming past a bizarre object called 2014 MU69, later named Arakoth, which means sky in the language of the Powhatan people. That's 1.5 billion kilometers past Pluto. And New Horizons got as close as just 3,500 kilometers above its surface. Floating silently in the darkness, Arakoth revealed a form unlike anything we'd ever seen. A strange, flattened snowman shape made of two lobes gently fused together. This peculiar form wasn't just visually strange. It challenged everything we thought we knew about how planets are born. Arakoth may only be about 35 kilometers long and 10 kilometers thick, but this tiny frozen body held massive scientific revelations. Instead of being a chaotic jumble from violent space collisions, Arakoth was smooth, peaceful, almost delicate. Its two lobes had joined slowly, without high-speed crashes or scars. This pointed toward a cosmic phenomenon called local cloud collapse, a gentle gravitational gathering of nearby particles, rather than the previously popular idea that planets formed through violent, fast-paced impacts. This was more than just a quirky shape. It was solid evidence supporting one of the biggest theories in planetary science. Alan Stern, lead scientist of the New Horizons mission, even called the discovery a decisive moment in a decades-long debate about how the building blocks of planets form. And all of this came from a single frozen object billions of kilometers from home. It proved that even the smallest, coldest, and quietest bodies in space can have the loudest stories to tell. And then there's Pluto, the frozen world we all thought we knew until New Horizons gave us a front-row seat in 2015. For the first time, we saw its surface in stunning detail: jagged ice mountains, mysterious haze in its thin atmosphere, and, of course, the unforgettable heart-shaped region called Tombor Regio. But did you know that this heart isn't just a poetic symbol? It's an active, dynamic glacier. The western half, named Sputnik Planitia, is a massive nitrogen ice plain nearly 1,000 kilometers across and up to 4 kilometers deep. It's the largest known glacier in our entire solar system. Meanwhile, the eastern lobe appears lighter due to nitrogen snow carried over and deposited from the western plains. Pluto's moons, Charon, Nix, Hydra, Kerberos, and Styx, were also observed in detail, adding even more layers to this distant system. Through New Horizons, Pluto transformed from a mysterious dot in the sky into a vivid, complex world with active geology and icy beauty. It reminded us that even on the edges of the solar system, the universe never stops surprising us. Imagine discovering that Pluto, our beloved dwarf planet, is far more fascinating and complex than anyone expected. Thanks to the New Horizons mission, not only did we get stunning close-up images, but the data reshaped how we understand Pluto, revealing clues about its mysterious heart-shaped region. Initially, some scientists thought this heart might be the sign of an internal ocean of water ice beneath Pluto's surface. But a recent study led by astrophysicist Harry Valentine from the University of Bern points to a different explanation, one that's surprisingly familiar. It suggests that the heart's western half was formed by a slow angled impact. Imagine skipping a water balloon across dry pavement. When it hits, it bursts, leaving a long, splattered shape. This is very much like how the western side of Pluto's heart may have been created through a low-speed glancing collision, but the revelations don't stop there. New Horizons also captured incredible images of Pluto's largest moon, Charon. Among the most eye-catching features is a vast tectonic belt around its equator, evidence that hints at a once-existing ocean of water ice beneath Charon's surface. These insights deepen our understanding of the Kuiper Belt and the solar system's origins. Looking ahead, New Horizons is expected to exit the Kuiper Belt between 2028 and 2029, though it might get a new mission target to explore next. Future tools like the James Webb Space Telescope will help us study Kuiper Belt objects in even greater detail. Someday, robotic missions could land on these icy worlds or even bring samples back to Earth. The Kuiper Belt is a vast, frozen frontier, still full of secrets waiting for humanity to uncover them, one icy object at a time. Thanks for watching, and a huge shout out to our Patreon supporters who help keep this science content free and available to everyone. If you want to join the community, get ad-free videos, see your name in the credits, and ask questions to our team, check the link in the description. For more amazing astronomy content, click on the playlist linked here. See you next time. If you liked it, don't forget to turn on notifications and click like. Thank you and see you soon.